This is for Year 12 Further Maths. We're going to look at question 20 from exercise 19b. Okay, so this is to do with the Earth's geometry. We're going to look at parallels of latitude and finding the arc length of the shortest distance within a small circle of a globe. Okay, so the position of Salzburg is 48 degrees north, so that's the remember, north and south is the latitude, and 30 degrees east, that's the longitude. Okay, so longitude, latitude. And we know Seattle happens to have the same latitude as Salzburg. Okay, so we want to find the distance around the 48-degree north parallels of latitude between Seattle and Salzburg. First of all, I like to draw a sphere just to show you what I'm talking about. So this is the Great Circle, that's equator, okay? And we know that Salzburg and Seattle are both 48 degrees north, so it's actually on a small circle that's above the equator. So this is what you call a small circle, because the equator is known as the Great Circle, but this is a small circle, okay? So any circle above or below the Great Circle will be a small circle, okay? Why is it a small circle? Because the radius of a small circle is not 6,400 like this one. Okay, so if you were to find the radius of that would be 6,400, whereas this would be something different. Now we know that Seattle and Salzburg are 30 degrees east in longitude and 122 degrees west. Okay, so if this was the meridian line, so this was the Greenwich meridian, 30 degrees east would be somewhere here, and 122 degrees west would be somewhere, let's just say over here. Okay, and what you're trying to find, essentially, is, if I draw an arc, this is the arc length I'm trying to find. So this would be the arc length I'm trying to find. Okay, so let's draw the actual arc. It will look something like this. Okay, so we've got 122 degrees west and 13 degrees east, and you're trying to find this arc length. Okay, now first of all we need to find the angle and we need to find the radius, because remember the radius isn't, since it's not on a great circle, it's not like size 400 anymore. Now there's a cheat formula you can use to get the radius, because the radius of a small circle is given by 6,400 cosine of the latitude. Okay, so we know the latitude is 48 degrees. So all you need to do is use your CAS calculator to calculate what the actual latitude is. Okay, so let's go 6,400 cosine, make sure in degree mode, cosine of 48. And we get 4282, 42824359. 4282, 4282, 4359 kilometers. Okay. Now we know that this is 4282, 4359. The angle between the two locations, the theta, would be, but since one is west and one is east, you just add the angles, okay? So 122 plus 13 should give you 135. So this is 135 degrees, the angle between two countries within the same small circle. So I've got the elements I need to calculate the arc, because I've got the angle and the radius. That's all I need. So let's go ahead and do it. So distance along the small circle is given by pi r theta on 180. That's the formula for an arc. Pi times r, 4282.4359 times theta, 135 divided by 180. Oops, 180. So let's work out what that equals to. Now, remember, I always advise students to use the exact values, because we've calculated the radius before. You can just copy and paste. So copy and paste here, times by 135, divided by 180. and that should give me the arc length. 10090. Okay, 1090 kilometers. Okay, so with all small circle questions, um, especially when I ask you to find the distance within the small circle, make sure you use this formula because that gives you the radius of the small circle. Because without the radius of the small circle, you cannot work out the arc length. Okay, so there's a difference in the radius of a big circle, of a great circle, compared to the radius of a small circle. If it's the radius of a big circle, you can use 6,400 as a radius, because that's the radius of the Earth. However, a small circle is slightly different. So, hopefully that helps you understand how to do the stuff problem.